Hi everyone, I'm Azlan and I will be taking you through the presentation for our project MedNourish AI. So, starting off with the features, we primarily offer three features. We have a medical report analyzer, we have a medicine information assistant, and we have a food nutrition analyzer. So, coming on to the healthcare challenges or the motivations for our project, essentially, there are three key challenges with existing solutions. The first one is the fact that they rely on outdated medical knowledge. Now, as we know, medical knowledge is constantly being evolving, and guidelines keep changing. So we need a tool that relies on data that is constantly being updated. There's also the lack of personalization. So LLMs don't typically have access to your past medical data. So that's something that we need to consider as well. Uh, Hallucination in AI is another problem. This is fairly typical in LLMs where they give you the incorrect response and they give it with a lot of confidence, so you don't really know whether to trust it or not. And this is significantly risky, especially in medical context. So we target all of these three by creating a RAG powered solution. So this is a system architecture and flow diagram. There are two parts to it essentially. This first one is in the hands of the medical authorities, and they will be given the task of updating this knowledge base. So they take a collection of relevant medical literature, and then to be able to push that onto a database, we first have to vectorize it. So we use an embeddings model. We are using Hugging Face, our model provider, and convert this into a numerical representation. We take that, push that onto a database, and at the end, it should be comprising of all of these different kinds of medical literature. Now, as a user, you can upload your report, either as a PDF or you can take an image, and then you can ask a query regarding this report. Then the similar process is done. It takes your query, passes it through the embeddings model, create a vector for it, and then it's going to run a similarity search between the knowledge base and your query. The relevant context is retrieved, and that is passed to the large language model, which then gives you an input into the chat interface. Now, these are the results for RAG versus traditional LLM response. Now, just for a common denominator to make the comparison easy, we are using the same model provided by Gemini. In both these cases, the difference is in the fact that this one is actually supported by RAG. This one is just a standalone LLM. So same report, same query, and same model, but ours is using RAG. So I can ask it a very simple question: are the vitamin D levels normal? Uh, and it just says no, the vitamin D levels are not normal. The report shows a level of 85 nanomole per liter, which is below this range, which is obviously incorrect. I mean, look at the range and look at the answer. This should fall in this range. If you look at our answer, which was sort of reinforced by the RAG, it gives you the correct response and also the relevant passages. Also, you don't have to take the response of our LLM, just blindly. You could actually click the tab below it to look at the context it has retrieved and use that, to further enhance your trust in the response. So that's it from my side, and I'll be handing over to Shubham now.
Hi, myself Shubham here. Uh, Let me walk you through the project implementation that we have done in this hackathon. So this is our homepage. As you can see, this homepage is made with the help of Next.js and ShadCN UI as well as the Tailwind CSS library. This, as you can see, this app is hosted. This app is hosted with the help of the Vercel. Here we have deployed our application. So here are some of the features we have mentioned over here. So let me take you through the first feature of our project, that is the analyze food product. So here is the example food products that we have hard coded. Here you can upload the image as well, and here you can take the photo. So let me first show you how it works, right? Let me click on analyze product. So it will take some time. It is fetching the data from the Google LLM. So here it is giving the nutritional rating, ingredients breakdown, whatever the ingredients are there, a simple explanation about whether it's vegan and how it uh, what are the considerations that it has taken in giving the rating to. So also you can upload an image as well from your computer as well as from your mobile phone. So I have this image here of the peanut butter. So let me analyze this product for you. It will take some time. And here is the nutritional rating, that is 3 of 5. And here is the simple explanation, whatever the ingredients are being used, some of the recommendations, and some of the what are the disclaimers, right, about the product. Also, you can take a picture and from your mobile phone directly and show it to this, and it will give you similarly the output. But as I am recording now, I can't show you, but you can try it out on our website. So let me walk you through the code of this. So here is the page. So here we have used the Lucid React for the icons, as well as we have used the shared CN UI for the UI components. As you can see, whenever the user clicks on the hit or hit on the click analysis, it hits this API called API analysis. So what does this analyze API route does is we uses the Google generative AI. We have used the Gemini 1.5 Flash model over here. So what this does is we use the system prompt to prompt the LLM that to act as a food product analyst. So we have given some of the instructions to the Gemini API model, like we want you to read the ingredient list from the image, and on the basis of that provide some recommendations and a simple explanation to the user, right? As we can see over here, it's the output of the LLM is not in a formatted way. So we have used the React Markdown library in order to format this data. So coming back to a second feature, that is the medicine GPT. So what it does is it searches for the medicine and the user can chat about the particular medicine in context of that. And let me search for Crucine over here first. It will take some time. Yeah. So it's the information of Crucine. Its generic name is paracetamol. It will provide the description, some indication and the usage, and the warnings, dosage, and administration. A user can chat like, when should I take it? So here is the response from the LLM. So medicine search and chat, it's not a simple output by the LLM. As we all know, LLM sometimes hallucinate the data. So we wanted that the medicine data should be genuine. So in order to ensure that genuinity, we have included the FDA API key. So what is the FDA API key does? FDA means the Food and the Drug Administration. It's handled by the United States. So what it does, it queries to this API point with the name of the medicine that the user has searched. So let me, uh, so medicine. So here we have written two functions. First is the search FDA. What it does, it calls with the help of the brand name, as well as it uses the generic name. Uh, if if this if the particular medicine searched by the user is not available in the FDA database, what it does, it automatically tells the Gemini model to search for it and give the output. So the output will be in this format: name, generic name, description, indications, and warnings, and the dosages. So the on the basis of the medical context, the user can chat if there is an FDA data, the user can chat basis on the FDA data, or basically the LLM. So let me search aspirin over here. Okay. So here, as you can see, the response was fast because it was from the FDA API key. So let me search. Let me click on this. So it will return me some description, indication and usage, warnings, dosage, and administration. Now I can chat about it. When should I pick it? So it is answering on the basis of this. Okay, now my colleague Varad Sankhe will explain you about the medical report analysis.
Myself Varad Sankhe. So now let's dive deep into our project. This is uploading page
of our project, in which we load the PDF or the text file that needs to be uploaded in the vector database, that is a Pinecone. Pinecone is used for retrieving and storing the high dimensional vectors. Index are the collection of the vectors, and namespaces are the logical grouping of those indexes. Okay, so when I hit the refresh button, it will load the file names that are currently stored in the document folder of a code. Okay, so now let's fill these details. Okay, I'm filling these details. Index 1. Okay, so I will be clicking the start upload button. Once I click on it, the progress bar will appear, which will be taking some time for doing all its processes. So now let's wait. As you can see, the file name, which is or the PDF which is being uploaded, and the number of chunks. Okay, so now we can test it here. Okay, let's refresh it once. Uh, as you can see, the number of chunks that are being uploaded and the test cases. So now let's understand the code of that following page. Okay. So this is the file list interface. So it is used for displaying the names of the files which are currently stored into the document folder. Okay. It uses the get file list API route. Okay. Get file list API route uses the FS library, which is a Node.js library for reading the files from the specified folder. Okay, so here the folder is documents. Okay, so after that, the name of the file will be forwarded to the UI components for displaying purpose. Then on start upload is a function which is called when the upload button is clicked. Okay, it uses the update database API. The update database API consists of uh, parsing the index name and the namespace on the UI uh, as per as the user enter, and it will call hand upload function. Hand upload function uses the PDF loader and the text loader for loading the PDF or the text file from the document folder of the code, and it will be using the chunking library of the JavaScript for creating the chunks of it, so it doesn't become intentionally heavy for uploading those all of the data into the Pinecone. So here I have also initialized the Pinecone API key. After that, the update vector db function will be called, uh, which uses the following parameters here. Okay. After all of this process is done, the following file name, total chunks upserted is complete. All of this data variable will be passed to the UI components. These are the all the data are used by the progress bar for displaying that for the displaying purposes. So now after that, the process string progress function will be called, which is the main function of the progress bar. In this progress bar, it displays the name of the file, the total number of chunks, the total number of chunks been uploaded into vector database, the progress of the uploading process. So this is all of the code, and this is the UI component and the UI code of the following page. Okay, so now this is our the this is the uploading process of the file or the PDF into the vector database. Now let's get into the user flow page. Okay, so user flow page is the following. So first of all, we have to select the file locally. So here I am selecting this one. So after uploading the file locally, we have to click on the upload file button. It will take some time for extracting purpose. It will create some summary about it. So as you can see, the summary has been generated. After the summary has been generated, we'll click on the looks good button. So it will pass the context to the chatbot for the additional purposes. So we can know what is key finding from this report. Okay. Now we'll send the message. It will take some time for loading the message. Okay. So this is the response from the Pinecone database, in which we uploaded this following book for the most of the key findings
and it contains all of the diagnosis. And I have submitted this report as a sample report for the testing of this purpose. Okay. So these are the key findings given by the Gemini API and the Pinecone additional insights and the given report context. Okay. So now let's understand the code of this following way. First of all, we have initialized the Pinecone and Google API. Pinecone is used for RAG purpose, that is retrieval augmented generation, and Google is for text generation purpose. I have set the Google generative AI configurations here. Then we are retrieving the relevant embeddings using the query Pinecone vector store function, in which we are specifying the index name, namespace name, and the query specified by the user, so that we can get the relevant embeddings from that. Okay. Then we are creating the prompt, which will be further fed into the Google Generative API. In this prompt, I have loaded the retrieval, that is relevant insights, then user query, user report data. Okay. So this prompt will be fed to the Google Generative AI here. Once the Google Generative AI process the prompt and give us the output response, we will convert that output response into suitable format that can be used for listing onto the UI component. So this is a function used for it. So this is all about our project. Thank you very much.